Hello there, 10th graders, and welcome to our physics class for week number 14. One more time, thank you for all of the effort that you're doing into completing our online lessons and, of course, all of the exercises that we assign weekly. Keep it up, please. Before we start, we're going to follow the general instructions that we already have. Log into Agilex, enter the Google Classroom, download your Word document, and save it in your physics folder. And of course, name it in the following way. And as we move, remember to take notes. That is very important for you to keep track of the most important things that you can hear from this video and PowerPoint presentation. It's always important to start with our end in mind. And this week we're going to study two topics. We're going to study topics 2.07 and 2.08. And our end in mind for the week is the students will be able to manipulate equations adequately and use critical thinking skills to complete acceleration-related exercises. So this is something very important to keep in mind. We're going to find several formulas related to acceleration, but in the problems that you are going to encounter later on, there might not be the formula that you need to use in order to find what you're being asked to. So in order to have the formula to find the information that they are requiring in the platform, then you need to remember a little bit the rearrangement of formulas that we studied last week. That is something very important for you to take into account. So just like it was mentioned, today we're going to study two topics and they both are related to acceleration. Acceleration is usually confused by students since we use it in our daily lives. And we're going to analyze two terms that are very important that you're going to find later on. So you can take that into account and you can fully understand what acceleration actually is. It is important to analyze two concepts: accelerated motion and non-accelerated motion. I'm going to give you some examples later on so you can have that concept clearly. So just before we continue, here I have a picture for you that represents what acceleration and what velocity is. So acceleration can be, for example, 1 meter divided by seconds squared. And velocity can be 4 meters divided by seconds, or meter per second. Okay. There is something interesting to analyzing here, and there is a mistake in this image. And I would like you to think about it. What is a mistake in the image? So, probably you have spotted already, but basically the mistake is that there is a very huge difference between velocity and speed. Remember that? A velocity needs a certain direction, and where it says velocity, it should be specified that it is moving forward, okay, in order for it to actually be a velocity and not simply speed. All right, now we're going to have a exercise. So please go to page 1, complete the exercises for non-accelerated motion and accelerated motion, and come up with an analysis of the differences that they have. So you can pause the video right now. You can go to page 1, complete those exercises, and once you're done, you can come back here so we can have a small discussion about it. All right, so welcome back. Now I'm going to give you a very small summary on what you had encountered in the online platform. Let's start talking about non-accelerated motion. So, in non-accelerated motion, the speed remains the same. Just like in the example that you encountered in the online platform, you can see that there was no change in the speed. And it covers equal distances in equal time. So if I'm not mistaken, the object that you were analyzing moved 1 meter per second or something like that. But there was basically no change at all. Now let's go to accelerated motion. So basically accelerated motion in it changes the speed. You could see that it had an increase in speed in the example that they gave you when the ball was coming down from a hill. And it does have acceleration. So what happened in the non-accelerated motion, and since there is no change in speed, then there is no change in the acceleration. But in the second example, the object actually had acceleration in it. And it covers different distances in equal times. So you can see that the more time it went by, the more distance that it started to cover. And you had to predict what was the following distance after it had gone through a certain time. Keep in mind that the first person that studied this and discovered was Galileo Galilei. That's a little bit of history. And here we have another image that represents what happens to the speed when it has a certain acceleration. At first, the object has a speed of 30 miles per hour, and then it changed to 32 miles per hour after 1 second. So what does that tell you? It tells you that basically the object is speeding up, and its acceleration will be 2 miles per second, basically. All right, let's continue with our summary. And velocity can change if you modify the direction, speed, or both the direction and speed of the object. Remember that I just mentioned before the difference between speed and velocity, and remember that velocity is speed, but it includes a vector as well. For example, 5 kilometers per hour north. That would be velocity. If you just say 5 kilometers per hour, then that will be speed. The change in velocity can be known as acceleration, of course. And here's something very important to analyze. We have acceleration and deceleration. So, the acceleration is basically when the speed of an object is increasing, but deceleration happens when the speed of an object is decreasing. But both classify as acceleration. And there is a misconception from a lot of students, and they think that acceleration only means getting a higher and higher speed, when in reality it can also be getting a lower speed. Now we have to analyze the equation that we have for acceleration, and basically this is the formula that we have for a basic acceleration. So A will represent acceleration, BF will represent final velocity, VO will represent initial velocity, and letter T will represent time. There is something very important for you to notice. Since this is PowerPoint, it's very difficult to get the appropriate symbols for each one of them. So it's better if you go to the online platform and double check the symbols. I'm talking specifically about the final velocity and initial velocity, because certainly letters F and O will be way smaller than letter B in there. So please go and double check them in the online platform so you can take it into account. We're going to have a small problem related to acceleration. So a ball is starting from rest rolls forward to 40.0 centimeters per second in 4.0 seconds. Find the ball's acceleration. This is going to be very simple, but remember that we already standardized a process that you need to follow in order to solve a problem like this. So first of all, you need to write down your givens. What information do you have with you? First of all, we have that we need to find the acceleration. Of course, so acceleration will just have a question mark. Do you have a initial velocity? Yes, you do. Because notice that it is telling you that the ball is starting from rest. So when an object is resting, it means that it is not moving at all. So if it's not moving at all, we will have our initial velocity, that is 0 centimeters per second. Do you have your final velocity? Yes, you do. the final velocity of the object is 40.0 centimeters per second. Lastly, we have our time, that is 4.0 seconds. All right, now that you have your givens, let's start working on the formula. Let's just substitute the values that you have right there and find out about the result. So here we have that we substituted everything, and there was no change in the first operation, the one that is above the division, because the initial velocity is 0. So we just divide 40.0 centimeters per second divided by 4.0 seconds. What is the result? The result is 10.0 centimeters per second square. This is something very important. If you don't write centimeters per second square, then your answer will be wrong. All right? Now let's analyze our answer. So our acceleration will be 10.0 centimeters per second square forward. Remember, we need that vector. We need to know in what direction the acceleration is going to. All right, let's continue. So we have some acceleration units. So this is a meter per second square. And one more time here, because it's PowerPoint and it's difficult to get the units in the way they usually look like, I suggest that you go to the platform and you double check what they look like, okay? They're not way too different, but if we talk about seconds, for example, then you will notice that it will not be seconds multiplied by seconds, but it will be just s and a small 2, which will represent to the second power. We have kilometer per hour squared, centimeter per second squared, and keep in mind to include the vector in the final answer. Just like I mentioned before, we have 35 meters per second squared forward. It's very important to have all of this in mind so you don't mistake all of the concepts that we have studied, including speed, acceleration, velocity, etc. All right, so now we have an exercise. What other additional formulas can you find in page 2? Remember, this was just the initial formula that we had, which is based to understand acceleration. But we have some others in the platform, so go ahead and find out more formulas. And you have to complete all the problems you find in page number 3. And before you go, I'm going to give you some more examples in here. There are some examples that you have to solve in page 3. So make sure to pay attention to them, and once you are done with this explanation, you can go and complete the exercises that were not solved. Let's start with a very simple problem. We have Luis's private jet starts from rest and achieves a lift-off velocity of 52 meters per second. Due east in 16.1 seconds. Calculate the average acceleration of the plane. Okay, number one more time, givens. We have our initial velocity since we started from rest. That is 0. Our final velocity, 52 east. We have our time, which is 16.1 seconds. Right, now it's time to work. We have our formula. We substitute the values that we have in there. We operate and we find that acceleration equals 3.23 meters per second square. Now let's just write our result correctly. Acceleration equals 3.23 meters per second square east. One more time, always remembering about the vector at the end. So this was a very simple problem, and it was pretty similar to the one I showed you before. But now we're going to jump to a problem that is a little bit different. So the engineer of a train traveling toward Orlando increases the velocity of the train uniformly from 7.2 meters per second to 15.0 meters per second, while traveling a distance of 75 meters. Find the acceleration of the train. Hint, you might want to rearrange the equation. So, one more time, and if you notice, right here we have something a little bit different. 75 meters, that is the distance, and that was a value that we did not have in the previous problem. It means that we might need to use another formula. We cannot use the regular formula for acceleration because we don't have the time. That's why we need to use a little different one. So here I have one of the formulas that you had to find in page number 2 in a previous exercise. And basically, this is the standardized formula for finding the final velocity square. But we're not interested in finding the final velocity, but we're interested in finding the acceleration, of course. So we're going to modify this one so we can isolate acceleration from here. And then we can operate and, of course, find the formula. All right, so after rearranging the formula a little bit, we will get this result. So basically, we have that acceleration equals the final velocity squared minus the initial velocity. It should be squared as well. I'm sorry, it's a little mistake in there. And we should divide everything by 2 divided by the distance. So here you have the values we have from the problem. We substitute them and we operate them. We have them right here. And we find that at the top we have 187.8 divided 150. So lastly, what will be our acceleration from the problem? We will have 1.32 meters per second squared towards Orlando, as it was stated in the previous problem. So it's very important that you keep in mind that the rearrangement of formulas is extremely necessary for all of these problems. So you will encounter other problems in which you will need to use different formulas to find the result. So it's great because we are going to keep on reviewing the topic that we had from last week. Anyways, any questions, I'm available in Google Classroom, or you can talk to me in the Zoom session that we'll have later. All right, so what is the evaluation for you this week? It's the following. Students have to read and summarize the content from the topic acceleration, as well as complete the exercises from this section. When they finish, they had to take the quiz for this topic. So remember to take the quiz for topic 2.07 acceleration. The students have to complete the lab report on topic 2.08 and then submit to the evaluation of this topic. Here's the manual lab simulation. So basically you have 2 options, which are a manual lab and the virtual lab. So I prefer that you use the manual lab simulation because I consider it's way better when you experiment things by your own. If you see it virtually, I mean, you have an idea and everything, but it's not like if you actually do it by yourself and you create the acceleration rules and laws that will be followed. So complete your lab report with the manual simulation lab and include pictures in your final report. I need to see that you had actually done your acceleration lab at home. So include some pictures of everything that you had created, the model I mean, related to the lab report. And that will be part of the things that I will be checking. You can check the rubrics on Agilex for both of the quiz and the lab report as well. And part of your evaluation will be to participate in a Zoom session. That will be it for today's class, guys. And thank you for coming one more time. I will be seeing you next week. Goodbye.